the last lecture we have studied about small test for small samples. Whenever the sample size is less than 30, then we may regard those samples as small samples. So for these small samples, we have two tests. One is this t-test and one is this f-test. T-test is used whenever we wanted to compare the means, and f-test is used whenever we wanted to compare the standard deviation or the variances. So I have given you the procedure to solve this t-test whenever you wanted to compare the mean of the sample with that of population. So these were the steps. First of all, you would formulate the hypothesis, then you would signify the level of significance and the associated degrees of freedom, and then you will calculate the test statistic t using this formula, where what is n? N is the number of elements present in the sample. Small s is the standard deviation of the sample, which you calculate using this formula, and x bar, that is the mean of the given sample. What is mu naught? Mu naught is the mean of the population which you wanted to test here. So according to that, we will first test the t hypothesis, t statistics, and then we will compute the calculated value for this t, and then we will make the decision based on the calculated value and the tabulated value. So let's see some examples corresponding to that. So here you may see that the table for t-test is given to be like this. So here, what is this nu? This nu represents the degree of freedom, and moreover the t subscript, that represents the subscript here, that represents the level of significance, right? So if you wanted to calculate the t-test for say 2 degrees of freedom at this 1% level of significance, or say for 5% level of significance, then you will go and look for the values of t where it is listed as 0.95, because we wanted to check for 5% level of significance. So for that, your value would be 2.92. So according to this, you will see this table. So this would be more clear to you from these examples. So let's have a look at our first example. So the example here, it says that specification for a certain kind of ribbon call for a mean breaking strength of less than 185 pounds. So the mean is given to be 185 pounds for the sample. So here they are saying 5 pieces randomly selected from different rolls have breaking strength of these values which are given to you here, right? So you are given a sample having how many elements? 5 elements, because only 5 data points are given to you, and then you are to test the whether the mean of the sample is equivalent to that meet the specification or not. So that means the specification is that given to you that ribbon call would have a mean which would be 185 pounds. So you are to test that the mean of sample, which is x bar, that is it equal to 185 or not. If it is equal to 185, you would say that your sample is significant. Otherwise, you will say that your sample is not significant. So as for the solution, our first step as always is to create the null hypothesis. Now what would be null hypothesis? We will say that the mean is equivalent to 185, because we wanted to check here whether the specifications are met or not. And for the alternative hypothesis H1, we will check that the mean, whether this is less than 185 or not, right? So from here you may check that this is what? This is a left tail test. So this is a left tail test, and here the mean of the sample is not directly given to you. So first of all, let me write down what is the sample. So your sample in this case consists of the elements, the data points that is given to you is 171.6, another one is 191.8, another one is 178.3, then you have 184.9, and then you have 189.1. So these 5 values are given to you. First of all, you wanted to calculate what is x bar. So x bar is the mean. So how would you calculate it? You would add up all the data values and divide it by total number of elements, which is 5 in this case. So you will obtain the mean as 183.1. So you would add up all these values, right, and then divide by 5. So you will have 183.1. The next task is to calculate the variance or the standard deviation. So for the sample, we have this formula 1 divided by n minus 1 multiplied by the summation of xi minus x bar square, right? So for that, you firstly have to compute this xi minus x bar whole square and then add up all the values and then divide by n minus 1. So when you do that, so let us do that. So let me write down here 189.1. So here it would be 189.1. So this is your xi. So what would be what would be xi minus x bar? So x bar here is equal to, so it would be xi minus 183.1. We have just calculated the mean to be equal to 183.1. So we will make a column here. So it would be 171.6 minus 183.1. So this would be the first value. Similarly, we will calculate the third value, fourth value and fifth value. And then what you do, you square this quantity because we require the square of this. So you perform the square here, and then you add up all these values here. So when you add up all these values, it would be summation of xi minus x bar whole square. So when you compute this s square, it would come out to be 67.24. You may check this quantity, and so that what is your s? It would be the square root of 67.24, so it would be 8.2 here. So now you have the value for s, you have the value for x bar, which is the mean. So we are ready to apply the t-test, right? So let's apply the t-test. Its formula you all know, it is x bar minus mu naught divided by the standard deviation s divided by square root n. So you have the value x bar, which you have calculated to be 183.1. Mu naught is given to you in the question, that is 185. So this is 185 divided by s, that is 8.2 divided by n, square root of n, and n is 5 here. So you have to solve this thing. So here you would have the value as minus 0.49. So this is your value of t which you have calculated, right? Next is to obtain the tabulated value for t. Tabulated value for t. So in this case, we are to look for two things. One is this degree of freedom. Another thing is the level of significance. So how to determine these things? So you have to go back to the statement of your question. So here you may see that 5% level of significance is given to you in the question. So we will test our hypothesis at 5% level of significance. Even if also it is not given to you in the question, you may assume it to be any value that you would like, so that your errors are accordingly. In this case, we are likely to make the mistakes 5% of the times, right? And our decisions would be correct 95% of the times. And here the degree of freedom, it is given by the formula n minus 1. So here what is n? So here the degree of freedom is given by the formula n minus 1. So what is the what is the value of n here? That is equal to 5. So your degree of freedom is 4 here, right? So therefore, what is the tabulated value for t? Your tabulated value for t for 4 degrees of freedom and for 5% level of significance is obtained from this table here. So you will check it for the table. Let's see what is the value. So here the value for 4% level, 4 degrees of freedom with 5% level of significance is this number, 2.13. So we'll write this value over here. So it is 2.13. So this is the tabulated value and your calculated value is this one. So therefore, we will test our hypothesis now. How can we test this hypothesis? So for that we have to see what is our critical region. So we will draw this distribution and here we will locate the point 2.13. So which would be the tabulated value. So according to this would be your critical region. If this is your critical region, so that means we will now check our value minus 0.49. So minus 0.49 means so here because our test is one tail test, how can you make that out? This is from this alternative hypothesis because your mu is less than 185. So that means we are talking about the left portion of the test. So according to that, your critical region, your tabulated value is this one. But for left tail test, the tabulated value at 4 degrees of freedom and 5% level of significance, this would be minus 2.13. So according to that, your value would lie somewhere here. So it would be minus 2.13. So according to this, the left portion of this minus 2.13 would be your critical region. If this is the critical region here, so now you will compare your values. So your calculated value here is minus 0.49. So minus 0.49 is obviously greater than minus 2.13. So therefore it will lie somewhere here, right? So it will lie in the region of acceptance. If it lies in the regions of acceptance, therefore we will accept our null hypothesis. So accordingly, if you accept the null hypothesis, your alternative hypothesis is rejected. And so what was your null hypothesis? It states that the mean of whole of the sample, that is equal to 185 only. So we conclude that the rows of ribbon, they meet the given specification at 5% level of significance. So here let me write down the conclusion. So we will say that the rows of ribbon meet the given specification at 5% level of significance. And in a similar way, we may have a look at one more question here. The question says a random sample of 10 boys from a large class of students have the following IQs. So these IQs are given to you for the given 10 students taken from a class. So we are to check here that whether the IQs of these 10 students, is it able to represent the IQ of all of the 100 students of the class, right? So here the population mean is given to you as 100. So let's get started. First of all, we have to formulate our hypothesis. So what would be a null hypothesis? Because here we wanted to test the mean of all these sample as equal to that of population. So this is for single mean. So we will specify the null hypothesis here as mu is equal to 100. If this is the null hypothesis, what would be your alternative hypothesis? We will say that the mean is not equal to 100 in this case. So here we have two-tail test. So after specifying this, you require, in order to calculate the t statistics, which is given by x bar minus mu naught divided by s by square root n, what all things you have? You have the value of mu naught, that is 100, divided by, you have the value of n, which is 10 in this case. So you require this x bar and you require this s. Now what is the sample that is given to you? The sample is given to us as 70, 120, 110, 101, 88, 83, 95, 98, 107 and 100. So for this particular sample, we will calculate the mean here. So how do we calculate the mean? According to the given formula, summation xi minus x bar divided by n. So when you add up all these and divide by 10, you have the mean as 97.2, and moreover your standard deviation, what would be that? So your standard deviation, or I may compute the variance here, it would be given by the formula 1 divided by n minus 1 into summation of xi minus x bar whole square. So when you compute this, you will get this to be 203.73. So you may calculate, I request all of you to calculate this. So once you calculate this, you may substitute the values here. So it would be 92.7, it would be square root of 203.7 divided by square root 10. So the value here is 0.62, right? So this is the calculated value for t. Calculated value. The next step is to mark the tabulated value. So for the tabulated value, what do you require? You will require here, now for this tabulated value, two things are required. One is the degree of freedom. One is the degree of freedom. So here the sample size is given to be 10. So we have 10 minus 1, that is 9 degrees of freedom. And moreover, the level of significance, that is given to be 5%. But here is a catch, that you will not use 5% here. Why? Because your test is two-tail test. So for two-tail test, what happens here? For the critical region, suppose this is the given distribution, so your 5% would make up all of the critical region. Now your critical region lies on both sides of this distribution. So one is this portion, another one is this portion. So here we say that your 5% is divided into two portions. So here we will check our result at 2.5% on both sides. So this is for two-tail test. So that means we will check for the value of t at 0.025, right? Or you may say that you may check your values at 1 minus 0.025 comma the degrees of freedom, which are 9. So what is this value? This would be t 0.975 and at 9 degrees of freedom. So let's move and see what value is available for this tabulated value. So at 9 degrees of freedom, we have to see our value for this one, for 2.5% level of significance, right? So your value here would be this one, 2.26. So let's substitute our value here. So it would be 2.26. So therefore your tabulated value, this number would be here plus 2.26, and on the left hand side it would be minus 2.26 because your distribution is symmetrical. Now because you have identified the critical regions, so these two are your critical regions. According to these critical regions, this would be your region of acceptance. So now you have to see where does your calculated value lie. So for that, your calculated value is 0.62. So 0.62 would lie somewhere here, right? 0.62, which is the calculated value. So therefore the calculated value lie in the region of acceptance. Therefore we will accept the null hypothesis. So that means, what was our null hypothesis? Our null hypothesis was h naught, which is equal to mu is equal to 100. So we say that, we conclude that the data is consistent with the assumption of mean IQ of 100 in the population. Right. So this is our conclusion.